Now we will see cycloid and involute curves. These are engineering curves, cycloidal and involute curves. Okay, and these two curves basically used in the designing of gear profile. We know when two gears are transfer the power from driver to driven, it should not cause for any loss of power due to slip. That means without slip, by rolling of one gear on the other, the power need to transfer from one shaft to another shaft. Okay, if we want to satisfy such parameter, then either cycloidal profile or involute profile we need to consider for the gear profile. Now we will see cycloidal curves first. First one is cycloid. And first one, by considering a straight path. Suppose cycloid is defined as when a circle rolls on a straight line without any slip. The point on the profile or outer profile of the circle, it will trace a path. That path is nothing but cycloid. That means the path traced by a point on the circumference of a circle when it is rolls on a straight line without any slip. That curve is called as cycloid. Now we will consider a circle here. This is the circle and this is the point P on the circumference of the circle. Now this is the straight line. Okay. Now this circle is rolls on this straight line for one revolution. Suppose without slip, if it rolls for one revolution, obviously the straight path covered by the circle is equal to circumference of the circle, that is 2 pi r. This length equal to 2 pi r. Okay. After the rotation, it will trace a path like this. By using our common sense, just if you consider P is the point which is on the circumference of the circle, initially it is on the bottom portion. If the circle covers half revolution, this point will transfer to topmost position. Okay, after completion of another half revolution, it will be here. Therefore, a curved path like this, we may expect, right? Now, to draw the perfect cycloidal curve, we will take one problem. After that, I will explain the respective methodology. Right? Note down. Here, draw a cycloid by considering diameter of the circle as 50 mm. Diameter of the circle is 50 mm. 50 mm. When it is rolls on a straight path without slip, and also draw tangent and normal to the curve at any point. Okay, right. To imagine this, first we need to calculate what is the value of 2 pi r, and we need to draw circle as well as straight line. Right, draw a circle with 50 mm. After that, by considering lowermost and here you need to draw a horizontal line of length equal to 2 pi r. 2 pi r or pi d is equal to 3.1415 into 50 mm. Okay, that is 157.5075 mm. Okay, first we need to consider at least this by neglecting the fractional portion 157 up to 157 we need to consider. Right, now this is the center C, center of the circle. Okay, divide the circle profile into 12 equal parts. That means each division is 30 degrees. Okay, exactly 30 degrees we need to consider. Okay, here the P. Once we rotating it, next division come into contact this one. Therefore, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Okay. Now, if we consider 12 equal divisions on the circle, we need to divide this line also into 12 equal divisions. Okay, for that, we know the procedure. Draw a line. This is a constructional line. It is inclined line. Any angle, any length we need to draw. Now, we need to consider number of equal divisions. This is 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash, 9 dash, 10 dash, 11 dash and 12 dash. Here 12 equal divisions I considered. After that, from last division to this division, draw a line. Right? Parallel line to this line. Parallel lines we need to draw so that the line which is equal to perimeter is divided into 12 equal divisions. Now this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Right. Now we will observe how the path will be. See, let us consider this is the circle of 50 mm dia, likewise. Right? This is circle of 50 mm dia and this is P point. Right? Now the circle, if it revolves on a straight path, see, if it rotates on a straight path, observe the path traced by the center point of the circle. Path traced by the center point of the circle. Path traced by the center point of the circle is a straight line. Okay, therefore, first draw a horizontal line like this, and up to this. Right? Now extend by considering this one. This is C1, or when the circle is rotates for first division. Okay, this is the position of the center. Next, this is C2. That means when the circle is rotated for 2 divisions, this is the position of center. Next, this is the C3. This is C4, C5, C6, C7, C8, C9, C10, C11, and this is obviously C12. That means when it is rotates for respective divisions, first position of the center we located first. Right. Next one. Another observation we need to do. This is the center. Right. And this is first division. When it rotates, see, this is rotates like this. And here you can observe this is the point P, and the point P lifted up, and the point P is on the locus line of 1 and 11. Okay, and if it is rotates for 2 divisions, now point P on the locus line of 2 and 10. If it rotates for 3 divisions, now it is on the 5 and 9. Okay, now it is rotates for 4 divisions. If it rotates for 4 divisions, this point is on 4 and 7 line. Okay, that means here due to the rotation, the point will occupy the position on the horizontal lines which are consequently occurs. Right? So that we need to draw horizontal lines through 1 and 11, 2 and 10, 3 and 9 already there. Now 4 and 8, 4 and 8. Next 5 and 7. Next 6. Okay, we draw the locus lines. Right. Now we need to observe another parameter. Whatever be the position of the circle, center to P, this distance, that is 25 mm, always remains same. Okay, always remains same. Therefore, this 25 mm as radius, C1 as the center, draw arc on the 1 and 11 horizontal line. Okay, now C2 as center, draw arc on 2 and 10. Okay, that means circle rotates for 2 divisions. Then C2 is the position of center. Center to the point P, that is 25 mm. Similarly from C3. After that by C4, C5, C6, C7, C8. Here the student made a mistake. Suppose if you consider C7, this is one position, this is another cutting obtained with the 25 mm. But when it rotates, the point will trace the path like this. Therefore, we need to consider the arc here only. Next, C9. Here, C10. Here, C11 and 12. Okay. Now, we need to give the notation P1, P2, P3, P4, P5, P6, P7, P8, P9, P10, P11 and P12. Okay, now draw a smooth curve through all these points. Right. I will darken the respective curve. This is the cycloidal curve. After completion of the curve, you need to write the title cycloid. Okay.